Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, well, I hope you're settling in for more A+, because that's what we're dishing up today. And joining us back in the studio, the head chef himself, Mr. Wes Bryan. Wes, welcome back, man. How's it going?
It's going great. I didn't know I was guest starring on an episode of American Iron Chef there. That's
right.
great.
That's
All
right.
right. Well, then we are serving up more of that installation of Windows for sure today. So let's go ahead and we'll kind of pick up right where we left off in part two. One of the last things that we did was a clean installation, and I did mention some of the post-installation configurations. We talked about, installing things like your third-party drivers. We showed you creating the first user account, setting things like your date and time, your regional settings as well. But one of the things that I really just mentioned, but I didn't show you anything, is the whole workgroup versus domain. See, if you're in a small office, home office environment, or if you're really just in a home environment in general, most likely what your Windows machine is going to be a part of is what's known as a work group. Now, Microsoft calls this a work group, but you might hear it called other things by, vendor neutral classifications, like for instance, a peer-to-peer network. And what that means is it's completely decentralized. We call a peer essentially an operating system or a series of operating systems that are all equal in the fact that sometimes they could be requesting a service or even offering a service. Let me give you an example of what I mean here. So if I have a printer that's connected to a machine, right? Well, that printer, I could share it out with the rest of the operating systems within that small decentralized environment. In that aspect, it's going to act like a print server, right? So other clients out there, other peers are going to request that, hey, I need to use your printer, right? Can I send that print job to you? Now we've got an operating system that's any old Windows client operating system, but it's acting like a server, and it could also be acting like a client, right? So it's a decentralized model in the fact that every user account is essentially managed and maintained by each individual computer. So if I wanted to have, let's say, a Wes user account, or W. Bryan, if that happens to be our, Wes Bryan here, W. Bryan user account, I'd have to go to every machine, right? And I would have to create a user account and make sure that the password is the same in order to log into all the machines. Unlike a domain environment, and a domain environment is one in which it's a centralized model when it comes to the management of user accounts, if you will, and it's a client-server type network in which we have specific clients that are requesting resources of other computers out there, and those computers that are basically providing those resources are called servers, right? Domain environment is something that you see inside of your corporate networks versus something that a work group is something you see in the home environment, and even really, again, small office, home office environments. I did want to mention one more thing when it comes to work groups. Work groups are limited in Windows to 10 computers. Anything over 10 computers, you have to move to the client-server model because, again, just administration being decentralized, it becomes an administrative nightmare, right? There's reasons we have terms like that because it just becomes very, very problematic to manage all the resources individually on each computer. Now, let me show you one of the things that can kind of tell you right away, not necessarily, but it could show you right away that you're in a domain versus a workgroup environment. You can actually see it right from the login screen. So let me show you what I mean here. So this computer is actually a part of a workgroup, all right? And when we look at it, you might notice something here is that it's just a basic logon. There's nothing crazy about it, right? And when I go ahead and I log in, all right, normal login, nothing different, but the login screen was different than this one right here. Notice that this one right here has a Control-Alt-Delete to log in. That's something known as a secure authentication sequence in the Windows world. It means that in order to interact with this computer, the only way you can log in is to choose Control-Alt-Delete. Now, since I've already logged into this machine before, notice that the login looked a little bit different, right? In the workgroup machine, it just said the username. Right? However, this is a domain joined computer, and notice that we have this name, a backslash, and then the username, right? Well, that is essentially the domain that this computer is a part of, and this is the user account within the domain, all right? And we'll go ahead and we'll get logged into this machine. Now, I do want you to know that there are there's a location that you can go to find out if your computer is joined to a domain or a work group, and that's through your system properties, right? Your system control panel, if you will. If we go to, well, the Start button, we go to Control Panel, System and Security, and System, we can see it. Now, we can also go, remember there's another way to get to this too. We can do Start, we can right-click Computer, and we can choose Properties, and I'll go ahead and launch it up from there. Now notice that in the System Control Panel, we have this computer name, domain, and workgroup settings. Notice that it tells me the full computer name here, all right? And let me kind of zoom out and get here. Notice that I'm part of a domain, right? And as you'll go on, when you go into your networking, we talk about things like fully qualified domain names, right? We talk about networking in general. We mentioned this type of naming convention, right? You have a host name or a computer name in this case, and then the domain name. But this lets me know that it's joined to the domain. All right. Now that being said, if we switch back over to this machine, we'll do the same thing. We'll go to Start. This time I'll go the long way around. Start, Control Panel, System and Security, just a couple different ways to get the same location, then System. Same thing comes up. But notice this time that it doesn't say domain right here, right? It says workgroup, and by default, this is the workgroup name that it uses. It's essentially nothing more than a BIOS name. Now, what happens if I wanted to join a computer to the domain? Well, from there, what I would do is I would go up here to the Advanced System Settings, all right, and I'd go to Computer Name, the Computer Name tab, and notice that it says to rename this computer or change its domain or work group, you click Change. All right. And then from here, what I could do is I could change the work group name if I wanted to join a work group, or I could join it to the domain. All right. And then here is where I would type in, oops, not that right there. I would type in demo and I'd click OK.
Now, an interesting thing about this, Wes, is that when it comes to work groups versus domains, with a work group, there's no type of authentication or trying to prove that you're a part of the group. You're one of the cool kids that needs to be in that work group. I just name my work group whatever I like, and if that happens to coincide with other people that have a work group, that name, we're all in the same work group, right?
That's absolutely correct, and let's go ahead and take that. I'm glad you asked that too, because let's take a little bit farther. Why is that happening? Well, every machine in a work group maintains its own user database, its own user accounts. Now, we've already talked about local user accounts in other episodes, so go back and check that out. But I'll show you where those user accounts are stored. If we go down to the Windows Explorer, File Explorer, depending on, it's all the same if you're talking about Vista, Windows 7, Windows 8, and 8.1. We go into Computer, Local Disk C, we go into Windows, and then System 32, and then we go into Config, and you need to be an administrator to get in here, and we will see this file right here. This is called the SAM file. Now the SAM file is the Security Accounts Manager file, and it's where the user accounts are stored within this machine that's in the workgroup. In a domain setting, right, this domain setting, my user accounts aren't stored, all right, well, local users are. But this administrator that we logged into that had demo /administrator, well, that's actually stored over here on the server. And if I get logged into the server, all right, then, and you don't have to know about Active Directory by any means, ladies and gentlemen. I just want to show you for the purposes of login why Dan's absolutely correct here. If I go to Active Directory users and computers, then essentially what's happening here is this administrator, its account is stored here over on the server, right? And I can create users in a domain in the centralized model, right? And that's the difference between a decentralized work group and how the work group works versus the domain. And that's why Dan's right. If it's a domain on the other side of that tracks, right? If it's a domain environment, I have to have some kind of administrative rights or at least a user within this database that we see in front of us in order to be able to log into the domain. So great question there. All right, so that is a little bit about your work group and domains. It's one of the post settings that we had to talk about that I really didn't mention here, and I wanted to go back and just kind of brief over it because it is called out in the objectives here. Now, the other thing that I also want to talk about, I talked about a clean installation, right? And we kind of skipped over what's known as an upgrade installation. Now, I will tell you that the upgrade installation could take a while, and for the most part, it really isn't much different than the clean installation. However, how you start it is a little bit different, and that's why I want you to be careful. Remember when we did the clean installation, all I did was I boot to the media, and I tell it exactly where I want to install. I load drivers if I need to, and I point to the location in which we're going to store it, right, on whatever the hard drive is or the partition. All right, let's go ahead and let's take a look at my Windows machine here, because this is how you would do an upgrade installation. All right, if I was to choose upgrade when we had upgrade or custom choose, it would have failed if I chose upgrade, and it would have said it can't install it, can't perform an upgrade from here. Because what you have to do is you have to put your installation media into the optical disk in this case, all right, or a USB thumb drive if it's bootable, and I have to point it and launch it from inside of the operating system. And this is a Windows 7 machine, and you can see here I got a Windows 8 machine. And what it does is it goes through the process of preparing the installation, and it gives me the ability to perform it from here. Now, I should be doing the download and install updates, right? Because what it's going to do is it's going to look at the hardware, it's going to look at the current configuration, the applications, and it's going to say, hey, let's reach out to Microsoft right now and see if they've got any additional software and updates that you should apply to this machine as part of the upgrade process to make it run more smoothly and have more stability. I'm just going to say no on this, and I'm going to choose next. And here it gives me the ability to enter my product keys, right? Now, I don't have any product key, and I'm not going to go through this whole installation, but because the installation, again, other than the first two radio clicks that you're seeing, radio buttons there, it's pretty much the same. But notice that I had to launch it from within the operating system versus the installation media where we chose custom. So I did want to just kind of call that out so you would be aware of it on the exam. Now, upgrades. Let's go ahead and let's continue along the path of upgrades, and let's talk about something known as upgrade paths, all right? Upgrade paths are something that are very, very important when you are considering whether an operating system can be upgraded or not, because you don't always get the ability to pick and choose which operating systems you can upgrade to. And here's what I mean. All right, you'll notice that I have a Vista, I have a little chart here, right? And we have Windows Vista, Service Pack 1, and Service Pack 2. If you have Home Basic, you can upgrade to Windows 7, Home Basic, Home Premium, and Ultimate. But notice if you have Home Premium, you're not going to upgrade to Home Basic. That's actually a downgrade. It's not an upgrade, right? So you have to be careful with this. Now, my head's kind of covering up this slide here. So one of the things that I want you to keep in mind is notice Business. Business doesn't upgrade from Vista to Home Premium. That's essentially considered a downgrade. But the Professional edition of Windows 7 is a lot like Business was in Vista. So it has the underlying architecture. You could, if you have a volume license, you could go to Enterprise or Ultimate and get all the features. Now, if you start out with an Enterprise edition, Enterprise to Enterprise is the only way you can go because it's a volume license agreement. I kind of mentioned that here just so you guys are aware of it. Now, notice if you already got Vista Ultimate, you can upgrade to Windows 7 Ultimate, right? Because they're not going to let you downgrade. It doesn't really make sense to have the highest the most features within Windows and then turn around and downgrade. Now, you also have what are known as in-place upgrades. All right, that's a different type of upgrade. It says I already got Windows 7, and I'm going to go ahead and I'm going to upgrade my Windows 7 box to a higher level edition, right? More features. Notice that I can upgrade Starter to Home Premium, Professional, or Ultimate. Notice Home Basic goes to Home Premium again because it's an upgrade, Professional, or Ultimate. And there should be a comma there. I'm missing a comma. Yeah. Home Premium, I can go to Professional, and I can go to Ultimate as well. Notice their Enterprise is nowhere in this list. That's because if you have Enterprise, there's nothing to upgrade to. You already have all the same features that you have in Ultimate and Enterprise are identical. The difference is volume licensing means you go through Microsoft because you're a corporation that can say, hey, I need more than 250 operating systems in a given life cycle of that OS. Professional, right? It does lack some of the features of Ultimate, so an upgrade would be to Ultimate. Now, the same thing goes with Windows 7 to Windows 8. Now, one of the great things about Windows 8, though, is that you only really have 3 editions of Windows 8, so it makes it easier for the test. Starter can go to Windows 8, which is kind of like their Home Edition, because they just don't call it Home Edition anymore, or Windows 8 Pro. Notice Basic, same thing. Home Premium, same thing. Gotta love it. It makes it a lot easier to remember for the exam. Notice Professional, well, guess what? Professional to Professional. Ultimate to Professional. So again, this list gets a little bit smaller. I like what they've done as they've gone to the newer models. You don't have hundreds of models to remember, right? Or editions, excuse me. Notice Windows 8, we can also upgrade to Windows 8.1. Again, Windows 8 can go to 8.1 or 8.1 Pro. Windows 8 Pro goes to Windows 8.1 Pro. And then they also had this one-off type of edition that's not available, I believe, in Windows 8 Pro anymore, or 8.1, and that's Windows 8 Pro with Media Center. That could also be upgraded to Windows 8.1 Pro. Now, guess what? It's a little bit easier when you look at Windows 8.1. if you have Windows 8.1,
Make it real simple.
you can upgrade to Pro. That's exactly it. So I know that seems like a lot. I realize that, but it might be something that they call out on the exam, because when you are going to install Windows, you have to know what the appropriate methods are going to be. Now, speaking of appropriate methods, last thing that I want to call out is partitioning. All right, and when we look at partitioning, what we have to understand is that, kind of like we've talked about in other episodes, we mentioned disk management. All right, and in disk management, when you have to install your operating system, we do want to talk about a couple different disk types. All right, you have what are known as basic disks, and you have what are known as dynamic disks. All right, now you can see disk 0 here. This is actually a basic disk. What is a basic disk? Well, a basic disk follows the old traditional PC BIOS format. It uses something known as master boot record, all right? And I'm going to get into the master boot record here in just a moment, all right? Master boot record has its limitations. When you do a basic disk, essentially what you get are 4 partitions, all right? Now, we can get around the 4 partition limitation, and we can create 3 primary partitions. A primary partition is a partition that allows you to basically have a file system applied to it. All right. If you take a basic disk and you format it and then divide it up into 4 partitions and you apply operating systems to them all, that would essentially be your limitation. However, one of the things that you can do is you can make one of those 4 partitions what's known as an extended partition. The extended partition essentially allows you to take that extended partition and then further divide it up into what are known as logical volumes. It's one of the ways Windows kind of gets around that old 4 primary partition limitation, right? So those are called logical volumes. However, what you don't get are the basic, the better features of what a dynamic disk gives you. Remember, in other episodes we showed you how to add an array. Essentially a software-based array through we did a striped disk, but I would have the ability potentially to, and it doesn't actually show it to you on here, but I would have the ability to create like a striped or a span or a mirrored volume, and I would basically be able to create a volume out of multiple disks. Well, that takes what's known as a dynamic disk. And if I convert this to dynamic disk, essentially what I do is I get around those limitations, right? And let's see here, it might cause problems on this. Oh no, it didn't give me a hard time. You got to be careful with it, and you got to pay attention to your compatibility. All right, so what this does is this allows me now that if I had additional disks, what I could do is I can aggregate them together, all right, and I also get up around that 2 terabyte limitation that we talked about in another episode. So you also have the ability to use dynamic disks. Now, dynamic disks, keep in mind, just allow for a lot better flexibility. Now, the other thing that I want to talk about briefly, I mentioned MBR. Now, MBR isn't on the exam, but GPT is, and I want to talk about both, because to me it doesn't really make sense to mention one and not mention the other. Why would we even move to GPT? What does that even mean? All right, well, for the longest time, the boot code, the master boot code that we've been utilizing has been, well, BIOS has utilized what's known as a master boot record, all right, an MBR. Now, an MBR has a flaw in it, and it really has some limitations. You have to understand that when BIOS was first invented, it was invented for 16-bit systems in 1976, all right? We're a lot farther past 1976, right? So Intel came out with what was known as the Unified Extensible extensible firmware interface, and they wanted it to become an industry standard, so they kind of gave it over to a consortium of multiple manufacturers, and they all worked together to kind of promote the standard.
Seems like it really worked out for them.
It really has. You know, they've done that before where they've come up with something that they've given out to the public, and essentially it becomes a unified or a consortium that gets standardized. So today what we have is what's known as the Unified Extensible Firmware Interface. It had its start with Intel's first EFI-based systems, but now to kind of distinguish the two, that it's an open market or an open standard, they call it Unified Extensible Firmware Interface. Now, Unified Extensible Firmware Interface doesn't use an MBR, all right? It uses what's known as a GPT, and that is called out on the exam, a GUID partition table. I want to compare the two so you know what we're doing, what's going on here. Well, this is an example of a master boot record, or MBR. And then the first portion of this code, you have what's known as the master boot code. Then you have what's known as a master partition table, and it limits it to 4 partitions, right? We said a 4 primary partition limitation. A primary partition just means it has a file system applied to it, okay? Now, if I take one of these partitions, I can create an extended partition and then essentially turn these into logical volumes and divide it up the way I want, all right? Then the last portion of this is called an end of sector. It tells you the end of sector. It's an end of sector marker, all right? Now, that being said, here's another limitation. Not only is there a 4 primary partition limitation, there's also a 2 terabyte limitation in the volumes. The other thing to keep in mind too is that master boot record could be corrupted. And if it was corrupted, the system would fail to bootstrap. It would fail to boot the operating system, because BIOS would say, I found the master boot record, I don't care what the condition is, I found it, my job's done. And then the operating system would fail to boot. So they came out with a replacement to it, and I'll kind of tell you guys what's going on here. You don't have to know all of this information, because there's 2 portions of this that are very, very important. But for those of you that are going on to more advanced training, are going to continue on and want to know this information, at least here at IT Pro TV, we can say we have given you this information. GPT is what's known as a GUID partition table, all right? And the GUID partition table doesn't have the 4 primary partition limitation, if you will, that the master boot record does. In fact, you get up to 128 partitions. So again, it kind of blows that whole limitation completely out of the water. All right, now it does, at the first part of this, have a protected MBR. And that's because a lot of the utilities that you have understand a master boot record. They don't understand the GUID partition table, right? Well, this protected master boot record is there, and it cannot be modified. The other thing is it has what's known as a primary GPT header, which is those GUIDs, those globally unique identifiers that tells us, again, where are these partitions. They're essentially entries. Now, here's what's really cool about this, and I want you guys to know. It also has what's known as a second GPT header, which is kind of like the master partition table is in an MBR. What does the GPT header do, the secondary one? Well, it's protected. And it's for fault tolerance. It's for redundancy. If, for some reason, this primary GPT header gets corrupted in any way, Unified Extensible Firmware Interface systems can continue to boot by using the secondary GPT header as a failback. And they can continue to bootstrap the operating system, and then this GPT header can actually overwrite the corrupted one, bringing it back to a good state. So we have fault tolerance and redundancy. And that's the GPT. So again, there's a lot of information in here. I know, ladies and gentlemen, I don't want you to worry so much about that. More so that I want you to understand that UEFI systems use GPT, BIOS systems use the master boot record. Understand the limitations of the master boot record. Also understand some of the things that GPT, the limitations that GPT allows you to overcome. Up to 128 partitions, drives well beyond 2 terabytes, and the fact that we do get some redundancy. All right, last thing that I want to talk about just real quick are the file systems that we have. They call out a few of them. I want you guys to know a little bit about the file system types that you guys have access to and the ones that you should be formatting for your Windows operating system. All right? They call out on the exam exFAT, FAT32, NTFS, right? These are the ones that we use inside of Windows. How, why, and where would we use them? NTFS is the file system of choice for Windows. It's what you should be using. It's the default file system, right? It has, essentially, it does have support for data integrity checks, right? It has support for permissions. It also has support for encryption and compression as well, even though compression isn't so important today with the fact that our drive sizes are just astronomically large today. But when this came out, drive compression was still important because drives were still relatively small. But it also has support for ACLs, access control lists, or permissions, if you will, as well as encryption, the ability to protect the information. exFAT. exFAT is a proprietary file system that was basically invented by Microsoft. It is adopted, if you will, by the SD Card Association, the ones that oversee the micro SD card specifications. And it is supported not only in Windows, but it's supported in Dan and my MacBooks as well. So if you need to move files between Mac and Windows, use exFAT, right? Because it'll be recognized by your Mac systems too. FAT32. FAT32 is an older file system. Does have a couple of limitations to it, but it is widely supported just by about everything, including cameras, including your different operating systems. It's got a lot of support. All right, it has a maximum volume size of 2 terabytes. Be careful with that, all right? The other thing to keep in mind is it has a maximum file size of 4 gigabytes. So those of you out there that like your high definition video, if you're transferring anything over 4 gigs, which is really easy to do today in today's day and age, you can't use FAT32. It doesn't have integrity checks, which means you can get file corruption very easily with FAT32, unlike some of the other file systems that we have out there. And it lacks security support. You don't get permissions, you don't get encryption. All right, so it lacks security support. There are a few other ones that they call out that you're not going to be using in Windows. Right? And what am I talking about? Well, not natively by any means. First of all, I'll get X3 and EXT3 and EXT4. In fact, Dan, being a Linux guy here, he looked at this list and was like, why are these even in here, right? These essentially are Linux file systems. EXT3 and EXT4. Again, they resemble UFS, the Unix file system. Just know that, again, they're going to be used in Windows. Or they're not going to be used in Windows. NFS is the network file system. It was invented back in 1984 by Sun Microsystems, back when Sun Solaris Unix-based systems. Again, it's similar to things like server message block, if you will, common internet file system, and Apple filing system too. It used to be called Apple Talk, as well as CDFS. CDFS was really for audio more than it was for anything. It later supported data too. But today we also have, and it's not called out on the objectives here, but I might as well go ahead and mention, and that's universal disk format too. In the show notes, if you want, I have some more of the specifics when it comes to, like for instance, knowing that EX3 has a maximum volume size of between 4 and 32 terabytes, file size 16 gigabytes all the way up to 2 terabytes. I don't know that if you're going to need to know that level of detail on the exam. So Dan, what I've done is I went ahead and put them in the show notes, and if you want a little bit more information and you want to kind of really get into what the maximum volume size is, I will mention NTFS here just for the exam because we are in a Windows thing, or a Windows show. Maximum volume size for MBR-based disks is going to be 2 terabytes. Maximum volume size for GPT, remember we said that it doesn't have that limitation, is 16 exabytes. That's 18 quintillion bytes, if you want to kind of wrap your head around that one. So again, we've got that in the show notes. If you guys and gals out there want to check that out, again, if you want to get specific for the individual things that you might need to know for the exam, know some of the basics as well, and you should really be good for the test. However, if you need to know it, it is there.
All right. Well, Wes, thanks so much for getting us familiar with what it takes to get Windows installed and some of the upgrade paths that we can look forward to if we're going to do that. Also understanding about disks and formatting and partitioning. Always good stuff to throw on the fire because when you're installing an operating system, it's things that you're actually going to have to do and understand. So definitely pay attention to that part of the series. But we are at the end of the little series inside of our normal series. So hopefully you guys have enjoyed it. And Wes, we do thank you for lending your knowledge to us. We thank you good folks for watching, but it is time to sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Wes Bryan.
We'll see you next time.
Thank you for watching IT Pro TV.